Now that your Databricks workspace is ready, let's take a quick tour of the platform. By the end of this lesson, you'll understand how the Databricks Intelligence Platform is organized, where the core data engineering tools are located, and how we use them throughout the rest of this course. But before we start clicking on some buttons, I want to leave you with a simple model of how to think about the Databricks Intelligence Platform. Nearly everything that you do as a data engineer in Databricks revolves around 4 core building blocks. First, you write your code. This could be a notebook in your workspace, or it could be a project file like a Python, a SQL, a text, or even a config file. Or it could be libraries that you build, like a jar or a wheel file. This is where you develop your data pipelines, define your data transformations, or even store your SQL queries. Second, once you've written your code, it needs somewhere to run. That's the job of compute. Compute refers to one or more virtual machines in the cloud that are specialized for the tasks that you want to do. We'll get more into that later in the next video. Just know that compute provides the processing power to run your notebooks, your SQL queries, and your data pipelines. Third, your code will probably read and write data. In Databricks, data is organized into catalogs, schemas, and tables, and is securely governed through Unity Catalog. Finally, you can run this manually, but eventually you're going to want your data pipelines to run automatically. That's where Lakeflow Jobs come into play. It orchestrates your data pipeline code to run and compute according to a schedule, or in response to an event, like a file landing on S3, for example. Even though that this is a pretty simple mental model, the data pipeline code runs on compute, reads and writes data, and scheduled by jobs. It's the foundation for everything that we'll cover throughout this course, so I highly recommend that you memorize this now. Now, let's put this into practice. Let's jump back into our workspace where we'll create our very first code artifact, a Python notebook. Now that we have our mental model in place, let's see how these 4 building blocks come together. I'm going to give you a quick tour of the areas I think you'll use the most as a data engineer, and then we'll create our first notebook. Let's start with the workspace. You can get to your workspace by clicking on the Workspace menu item from the navigation menu on the top left. This is where you organize many of your code assets you use to develop your data pipelines, mainly your notebooks and your Python or SQL files. In fact, think of this like your own development environment in the cloud. We're going to spend a lot of our time throughout this course right here. Next up is the catalog. This is where we'll explore the data side of our mental model. Now, your data in Databricks is organized into catalogs. And within each of these catalogs, there are one or more schemas. And again, within each of these schemas, there could be one or more tables. Now, everything that you see here in this catalog feature of your Databricks Free Edition is actually backed by a Unity Catalog Metastore. It provides you with centralized governance and access control for all of your data assets. Now, I know that might seem like a mouthful right now, but don't worry. We'll spend much more time here when we get to the data governance and security section of this course. Next up is compute. Remember from our mental model, we write our data pipeline code, but that code needs somewhere to run. That's what compute provides. It's the processing power that executes our notebooks and our data pipelines. There are several different types of compute available in Databricks. In fact, we'll dedicate the entire next lesson just to understanding compute. So for now, just remember that compute is what runs our code. Finally, we have jobs and pipelines. This is where we'll eventually take the code that we develop and turn it into an automated workflow. Lakeflow Jobs allows us to orchestrate tasks, define dependencies, and run workflows on a schedule or even in response to an event. Now, we won't build a job just yet, but keep in mind as a final piece of our mental model, jobs are what automate the execution of our code. Now, you may have also noticed other menu options too, like the SQL editor. It's common for data engineers to use this when they want to quickly explore or wrangle data using SQL only. And under the data engineering section of the navigation menu, you may also find tools related to data ingestion and data prep. We'll spend a lot more time here when we move into the second and third sections of this course. Now let's actually create something. Start by going back up to your workspace and clicking on your home folder. Click the drop down next to the create button and click on folder. Let's give it a name like lesson 1.2. Let's click that same drop down next to the create button, but this time select notebook. Every notebook has a default name, but we can change that by double-clicking into the text box. You'll notice that every notebook has a default language, which in this case is Python. We could always change it by selecting the default interpreter up here on the left. I'm going to keep it as Python. In fact, within the same notebook, you can mix and match languages using the language-specific commands like %python, or %py for short, and %SQL. Adding a new cell is as simple as hovering over an existing cell and clicking the plus code, and deleting it is as simple as clicking on the trash can icon. We can also add markdown cells to document our code and explain what we're doing. Finally, Databricks has a built-in AI assistant called Genie Code. It can help us troubleshoot, explain, and generate code directly within a notebook. We'll be using Genie code throughout this course to help us learn faster and work more efficiently. Another useful feature is version history. Databricks automatically tracks changes to a notebook, allowing us to see previous versions or even restore to an earlier version if needed. Lastly, notebooks were built for collaboration, meaning that multiple users can work within the same notebook, and teammates can leave each other comments directly on the code, asking questions, or providing feedback. Now, we don't always need to create a notebook from scratch. We can always import an existing notebook either from our local computer or from the URL, like a GitHub repo. Let's import a data generator we'll use for the hands-on exercises. Now, there's just one problem. We need compute in order to run the cells. Every code artifact in Databricks needs compute to run, and choosing that compute is an important skill not just for the exam, but also for real-world problems. In the next lesson, I'm going to cover all the different compute options in Databricks. We're going to create a cluster together, and then we're going to come back and run this notebook. I'll see you in lesson 3.